400 Hz electrical systems were commonly used in military aircraft, ships, and portable generators, particularly during the 1950s and 1960s. The reason for using this higher frequency was to allow for the use of smaller and lighter equipment, a significant advantage in military applications where space and weight are critical concerns. When a generator produces electricity, the frequency of that electricity, measured in Hertz, is directly related to the speed at which the generator's rotor spins and the number of poles in the generator's design. In simpler terms, a 400 Hz generator is designed to produce alternating current that cycles 400 times per second. This is in contrast to the 60 Hz standard used in many civilian applications, including household power, which cycles 60 times per second. The design differences between a 400 Hz generator and a 60 Hz generator are significant, impacting the size, weight, and operational characteristics of the equipment. Converting a 400 Hz generator to operate at 60 Hz is technically possible, but it's a complex undertaking that involves several key modifications. Firstly, the stator, the stationary part of the generator that contains the windings where electricity is generated, is designed specifically for a particular operating frequency. To convert a 400 Hz generator, it will likely be necessary to replace the existing stator with one designed for 60 Hz operation. This is because the number of windings in the core material of the stator are optimized for a specific frequency, and simply changing the rotor speed may not achieve the desired 60 Hz output with the original stator. Secondly, the voltage regulator, which controls the output voltage of the generator, will need adjustment or replacement. The voltage regulator is designed to maintain a stable output voltage at the designed frequency. When changing the frequency from 400 Hz to 60 Hz, the regulator may not be able to properly maintain the voltage, leading to instability or incorrect voltage output. A new voltage regulator designed for 60 Hz operation, or an adjustable regulator that can be calibrated for the new frequency, will be necessary. Thirdly, installing a frequency converter can be considered. A frequency converter is a device that takes in alternating current at one frequency and outputs alternating current at a different frequency. This device can convert the 400 Hz output of the generator to 60 Hz. However, frequency converters can be expensive and require their own power source, adding to the complexity and cost of the conversion. Some crucial considerations before attempting to convert a 400 Hz generator to 60 Hz are cost, technical expertise, and availability of replacement parts. The cost of converting a 400 Hz generator can be substantial, especially if a frequency converter is needed or if the stator needs to be replaced. These parts can be expensive, and the labor costs for installation and calibration can also add up. The conversion process requires specialized knowledge and skills. This is not a simple task that can be done without proper training and experience. Working with electrical equipment can be dangerous, and correct modifications can lead to equipment damage or personal injury. It is highly recommended to consult with qualified electrical engineers or technicians with experience in generator conversions. Finding replacement parts for older military generators can be a significant challenge. These generators may use non-standard components, and the original manufacturers may no longer be in business or may not carry parts for these older models. Sourcing the correct replacement parts can be time-consuming and expensive. Before attempting any conversion, it is essential to thoroughly research the availability of replacement parts and factor this into the overall cost and feasibility assessment. An alternative to converting the generator is to use it for its intended purpose in a military or legacy setting. If the generator is still functional, it can be used to power equipment designed to operate at 400 Hz. This may be the most practical option if the cost of conversion is prohibitive or if there is a specific need for 400 Hz power. Attempting the conversion without the necessary expertise is not recommended. Modifying electrical equipment can be dangerous and can result in serious injury or death. If you are not qualified to perform the conversion, it is best to consult with a professional. Here's a more detailed explanation of each step involved in the conversion process, along with additional technical considerations. Starting with the stator replacement, the stator is a critical component of the generator. It consists of coils of wire wound around a laminated iron core. When the rotor spins, it creates a change in magnetic field that induces a voltage in the stator windings, generating electricity. The design of the stator, including the number of turns in the windings, the gauge of the wire, and the dimensions of the iron core, is optimized for a specific frequency. Replacing the stator involves disconnecting the existing stator from the generator frame and electrical connections, removing it, and installing a new stator designed for 60 Hz operation. This process requires careful attention to detail to ensure that the new stator is properly aligned and connected. The new stator must also be compatible with the existing rotor and generator frame. Modifying the voltage regulator is another crucial step. The voltage regulator is an electronic circuit that monitors the output voltage of the generator and adjusts the field current to the rotor to maintain a stable output voltage. When the frequency is changed from 400 Hz to 60 Hz, the voltage regulator may not be able to properly control the output voltage. This can result in voltage fluctuations, overvoltage, or undervoltage conditions. To address this issue, the voltage regulator must be adjusted or replaced. Some voltage regulators have adjustable settings that can be calibrated to work with the new frequency. If the existing voltage regulator is not adjustable, it will need to be replaced with a new voltage regulator that is designed for 60 Hz operation. The new voltage regulator must be compatible with the generator's excitation system and output voltage requirements. Installing a frequency converter is a more complex solution. A frequency converter is an electronic device that converts alternating current from one frequency to another. It typically consists of a rectifier, an inverter, and control circuitry. The rectifier converts the alternating current input to direct current. The inverter then converts the direct current back to alternating current at the desired frequency. The control circuitry regulates the voltage and frequency of the output alternating current. Frequency converters can be used to convert the 400 Hz output of the generator to 60 Hz. However, frequency converters can be expensive and require their own power source. They also introduce additional losses into the system, reducing the overall efficiency of the generator. Before installing a frequency converter, it is important to carefully consider its cost, size, weight, and efficiency. When considering the cost, converting a 400 Hz generator to 60 Hz can be expensive, especially if a frequency converter is required. The cost of a frequency converter can range from several $100s to several $1,000s, depending on its power rating and features. In addition to the cost of the frequency converter, there may be additional costs for installation, wiring, and calibration. The conversion process requires specialized knowledge and skills. Working with electrical equipment can be dangerous, and incorrect modifications can lead to equipment damage or personal injury. It is highly recommended to consult with qualified electrical engineers or technicians with experience in generator conversions. They can assess the feasibility of the conversion, recommend the appropriate components, and perform the installation safely and correctly. Before attempting any conversion, it is essential to thoroughly research the availability of replacement parts. Older military generators may use non-standard components, and the original manufacturers may no longer be in business or may not carry parts for these older models. Sourcing the correct replacement parts can be time-consuming and expensive. Consider the wiring. Generators produce high voltage and current. Safety is paramount. Always disconnect the generator from any power source before working on it. Wear appropriate safety gear, such as gloves and eye protection. If you are not comfortable working with electricity, consult a qualified electrician. Before beginning any work, consult the generator's manual. The manual will provide specific instructions and diagrams for your generator model. Understand the generator's components. Familiarize yourself with the location and function of the generator's major components, such as the engine, alternator, voltage regulator, and control panel. Check the generator's condition. Before starting any work, inspect the generator for any signs of damage, such as frayed wires, cracked insulation, or loose connections. Replace any damaged components before proceeding. Disconnect the battery. Disconnect the battery cables from the battery terminals. This will prevent accidental starting of the generator while you are working on it. Label the wires. Use masking tape and a marker to label all wires before disconnecting them. This will make it easier to reconnect them later. Take pictures. Take pictures of the generator before and during disassembly. This will help you remember how the components are assembled. Store the parts in a safe place. Store the removed components in a safe place where they will not be damaged or lost. Keep the work area clean. Keep the work area clean and free of clutter. This will help you stay organized and prevent accidents. Follow the instructions carefully. Follow the instructions in the generator's manual carefully. If you are not sure how to do something, consult a qualified electrician. Double check your work. Before reconnecting the battery, double check all of your work to make sure that everything is connected properly. Test the generator. After reconnecting the battery, test the generator to make sure that it is working properly. If you encounter any problems, consult a qualified electrician. Generators require regular maintenance to ensure that they operate safely and efficiently. Here are some tips for maintaining your generator. Firstly, check the oil level regularly and change the oil according to the manufacturer's recommendations. Secondly, check the air filter regularly and clean or replace it as needed. Thirdly, check the spark plugs regularly and replace them as needed. Fourthly, check the fuel filter regularly and replace it as needed. Fifthly, inspect the generator for any signs of damage such as frayed wires, cracked insulation, or loose connections. Sixthly, store the generator in a dry place. Seventhly, start the generator periodically, even if you don't need it, to keep the engine lubricated. Eighthly, have the generator serviced by a qualified technician at least once a year. If the generator is still functional, it may be most practical to use it for its intended purpose in a military or legacy setting. Converting it to 60 Hertz could be cost prohibitive and may not be necessary for civilian applications.